Hi, welcome back to the model drawing lessons again. Now let's look at everything changes for today's lesson. All right, now, uh, okay, so we are going to recognize the concept of everything changes, and then we are going to apply the before change after tabulation, and also we are going to use a table to create equal units or parts. Wow, what does that mean? Okay, now you will understand later. Okay, so let's look at the first example, and it's about 4 marks, right? At least 4 mark question in the exam. So you have fractions, you have ratio, so it's a mixed topic. All right, let's see how we solve this problem using the table method plus the model. All right, now of course, your teacher may, when you go to school, your teacher may draw entirely model. Means the whole thing is all model, which is nothing wrong. All right, you can actually draw out the whole problem. But to make it easier for the weaker students, right? For those of you who are not so good in your maths and your drawing is not very good as well, so I will suggest to you two ways to use together. You can use a table, which you will see later, and then after the table, you draw the model. Right? So let's see how we do that. Now, Fanny collected 1/5 as many as Gary. So arrow pointing at the 1/5 as many seashells as Gary at first. Then Fanny collected 5 more seashells and Gary found 12 more seashells. The ratio of the seashells Gary had to the seashells Fanny had became 4:1. So it's a after, right? Before and after problem. How many seashells did Gary have at first? Alright, so what is unchanged or everything changes? Now in this problem, everything has changed. Fanny has more seashells now. Gary has also more seashells. Did they collect equal number? No. If they have collected equal number of seashells, the difference will be unchanged. So when something is unchanged, it is actually very easy to solve. No need to draw a model, right? No need to, if you're using the table, right, there's no need to draw a model for before and after problems. But because this is a model drawing lesson, all right, so we have to draw a model. But I want to make it easier to draw the model by using the table, right, the table method. Okay, but do take note that that is actually a very fast way to solve the problem without the use of model. Okay, and that method is called the before change after tabulation. All right, so I'm going to show you a bit of that today. Okay, now so how do we use the table to solve this problem? Now you're going to draw rows and columns like a guess and check table, and before change after, right? B before, C is change, A is after, and then you have Fanny, and then you have Gary, and then you have total. Alright, so how do you fill the numbers in the boxes? You always start from the beginning. So Fanny collected 1 unit, Gary 5 unit, total 6 units. Right? Very straightforward. Then Fanny collected 5 more, so just plus 5. Alright, so in the boxes under the change, either plus or minus, or sometimes you have divide and times as well. Alright? And then Gary found 12 more, so you plus another 12. Then the ratio of seashells Gary had to Fanny became 4:1. Alright, be very careful with the order. Gary comes first, so 4:1. Alright, sometimes in the exam papers, you find that it's quite tricky. So if you rush through your work, you will put down wrongly, right? It's actually 4:1. It means that Gary has 4, Fanny has 1. So you have to put in the right boxes. And then total is 5. And you can't call them units, you have to call them parts. Because you have used the units already, so you have to call them something else. So how many seashells did Gary have at first? And that's your question mark. And that's it. Okay, that's how you fill in the boxes. Alright, then how do we use the model to continue solving? Alright, now you are going to make the parts equal. Okay, make the parts equal. So you're going to take one part and you times 4. But do take note that Fanny doesn't have 4 parts in the end. You are just trying to make the parts equal so that when you draw the model, it is easier to draw. So your one part times 4, so in the whole column, everything also times 4. Okay, times 4. So, and then your table can flow downwards, which we'll learn more on this, right, under my heuristic lessons, right, but I won't be talking about why the table flows or how the table flows. Alright, so when you flow downwards, you can create your statements, which is 1 unit plus, or which is 4 unit. Fanny has now 4 units plus 20, because 5 times 4 is 20. That will give you 4 parts. So that is how you write out the statement. But do remember that that Fanny has 1 unit at first, and she has collected 5 only, 5 seashells, not 5 times 4, 20. All right, so it's just to make the model easier to draw later. Okay, then how about the next statement? You look at Gary. Gary has 5 units, and then he collected 12, and now he has 4 parts as well. Okay, so can you see the 4 parts and the 4 parts? Equal. So you are going to draw 2 equal rectangles, right? 2 equal rectangles, which is something like this. So 4 unit plus 20 equal 4 parts, which is the the whole rectangle. Then another similar rectangle, and 5 unit plus 12 is also equal to 4 parts. So now you can see why you want to make the parts equal, so that you can draw 2 similar rectangles. And then you can look at the model and you can find their differences. So what's the difference in the units? 1 unit. 5 unit minus 4 unit, you get 1 unit. What's the difference in the whole number, which is 20 minus 12? That is 8. So now you can see that your 1 unit is equal to 8. Oh, you can now come back to your table and get the answer. So Gary has 5 units at first. So how many did Gary have at first? 5 units. So 8 times 5, 40. And you solve it. Alright, at least a 4-mark question. So what have I done over here? I've used the table method with model together to solve the problem. Alright, so I think this is a little easier compared to trying to draw the whole model on its own. Alright, which is possible, but I think if there's something easier, let's go for the easier way. Okay, let's go to the next example. Okay, question number 2, and let's read. John had 2/5 arrow pointing as many kiwi fruits as Benny at first. Now, when you see fractions, you have to arrow point, because you need to know how to break out the fraction to draw the model or to put into the boxes, which is the table method. Right, John bought another 8 kiwi fruits and Benny ate 5 kiwi fruits. Then John had 4/5 as many kiwi fruits as Benny. Alright, so there's a typing error, right? Typing error. So which means that John has 4 boxes, or I mean has 4 in the end, and Benny has 5 in the end. Alright, and find the number of kiwi fruits that John had at first. So what is unchanged or everything changed? Everything has changed, right? John has more fruits. Benny has lesser now. Did they buy equal number of kiwi fruits? Nope. Did they eat equal number of kiwi fruits? Nope. So the difference has also changed. Okay, now, so again, if everything changes, I will always prefer to use the table, right? The table to help me to draw the model. So BCA, all right, and label the types of fruits, the different people, John, Benny, and of course total, right? Total. So your table always have the total column. So John has 2, Benny has 5 units. Total they have at first is 7 units. All right, then John bought another 8, so you plus 8, and Benny ate 5 kiwi fruits. All right. Okay, then what happened in the end? John had 4, and you call 4 parts. You cannot call 4 units, right? You have to use a different term. And Benny has 5 parts. Total will be 9 parts. So altogether they have 9 parts in the end. So find the number of kiwi fruits John had at first, which is your question mark. Okay, so here we go. How do we use a table to draw the model? So same thing. Can I make the parts equal? Yes, I can. Times 5 times 4. Okay, to make them equal. So if you times 5, the whole column here will also times 5. And then over here you also times 5. Oh no, times 4. Okay, times 4. So this column you have to times 4 and then times 4. Okay, but again, once again, be very careful. What are the correct values? The correct values are the green, right? The numbers in green. Okay, the units and the parts in green. So you times 5 times 4 is to help you to draw the model, which is equal rectangles, right? To draw out the 2 equal rectangles. Okay, so let's create the statements. You can flow downwards, right? So you flow downwards, and how would your statement look like? So you flow this way, that is 10 unit. So John has 10 units, then plus 40, which is 8 times 5, that will give you 20 parts. Okay, and then Benny has 5 unit times 4, which is 20 units, and then minus, okay, not plus, and then minus 5 times 4 is 20, so minus 20, and that gives you also 20 parts. So 20 parts, 20 parts, 20 parts equal. So now you can draw the model. So how do we draw the model? Alright, 10 unit plus 40, you draw a rectangle, cut 10 unit and 40, so the whole rectangle is 20 parts. Now if you see minus in the statement, then you just draw a little longer, and this is 20 unit and cut away here, cut away 20, that also gives you 20 parts, which is the empty box on the left side. Okay, and then you can actually fill in the boxes. So 10 units, alright, and then here is 40. Okay, alright, so let's recap. Okay, now 10 unit plus 40, that gives you 20 parts, which is the whole rectangle. 20 units, which is the longer rectangle, and you cut away 20 or minus 20, that gives you the same blue rectangle, which is also 20 parts, right? So your 20 parts is the blue rectangle. Alright, once you've done that, you can see how many units is how many. 20 unit minus 10 unit, you get 10 units. So 10 units is equal to 40 plus 20, which is 60. So your 1 unit is 60 divided by 10, 6. Now you can go back to the table, alright, and can you see John has how many units? Not 10 units, not 2 units times 5, but it's 2 units. So John has 2 units of kiwi fruits. So 2 units will be 2 times 6, 12. And you solve the problem. Okay, so you use the table and the model to work out the answer. Okay, now let's go to practice problem, and I'm going to give you about 10 minutes to do the same thing. So okay, once you're ready, you can pause the video and you can start now. Alright, so have you solved the problem? Let's read and find out. Now the spoons and forks in the restaurant was 3 to 7. After the chef bought 6 more spoons and 4 more forks, the spoon became 1 over 2 of the forks. Right, so arrow pointing when you see fractions. How many forks did the chef have after the purchase? Okay, everything changed, right? Now you have more spoon in the end, you have more forks in the end. Did the chef buy equal number of spoons and forks? No. If the chef has buy equal number of spoons and forks, then the difference will be unchanged. Alright, same thing. If everything changes, I always like to use the table, right? The table method. Okay, so that I don't have to think very hard on how to draw the model, even though I can. But let's not stress ourselves too much. If there's a better way to solve, let's go for the better way. Alright, so you have spoons, forks, and total. Okay? Alright, so the spoons and forks are in the ratio 3, 7, 10, and you call them units. Alright, now, after the chef bought 6 more spoons, so you plus 6, and 4 more forks, so you plus 4, the spoon became 1, so you have to call 1 part. You cannot call 1 unit. Once you have called units already, you have to call something, you have to use a different term, which is parts. And then the forks will be 2 parts in the end, and the total in the end is 3 parts. So how many forks did the chef have after the purchase? Question mark. And you are done. Okay, finish. That's how you fill in the boxes. Alright, once again, everything changes. How do we draw the model? Well, can we do what? Can we make the parts equal? Yeah, make equal parts. So if you times 2, the whole column also times 2. Okay, and then you flow with the table. Right, you can go down. Right, so when you go down, what statement do you make? You have 6 unit, 3 unit times 2 is 6 unit, and then 6 times 2 is plus 12, and then 1 part times 2 will be 2 parts. Okay, and then how about the forks? So you go down, so you have 7 unit plus 4 and equal 2 parts also, right? Equal. Okay, so now we're going to draw the model from these two statements. So you draw a rectangle cut 6 unit plus 12 equal 2 parts. Draw another similar length, which is 7 unit and you plus 4. Also equal to 2 parts. So you have two equal rectangles. Alright, once you've done that, then you look at the model and you find the difference. So can you find the difference in the units, which is 1 unit difference? Can you find the difference in the whole number? Yes, which is 8. 12 minus 4 is 8. So which means that your 1 unit is 8. Okay, then come back to the table. Can you find how many forks did the chef have after the purchase? Which is 2 parts. But I don't know how many is 1 part. I know 1 unit is equal to 8. So don't worry. Can you find 7 unit? So 7 unit is 8 times 7. That will be 56. So one of the guidelines to the table method is whatever numbers you have found, you put into the table. So that it becomes clearer and clearer like a model. And then now you can see that 56 plus 4 and you get 60. Right? Of course, you have to show your steps, how you get 60. So 56 plus 4, 60 forks after the purchase. So the chef have 60 forks in the end. And you solve the problem using the table and the model together. Alright, so I hope that at the end of the lesson, you feel more confident now on how to do before and after problems. Okay, but just to let you know, alright, the table method is very effective when it comes to even more complicated before and after problems. But in our model drawing lessons, we will spend more time, or rather a lot of time, on the model drawing, alright, on the model drawing itself. So we won't be using so much of the table, right? So if you want to know more about this table, okay, you will have to join another group of mine, which is under the heuristic lessons, and then I will show you how to use a table to solve even more complicated before and after problems. All right. Otherwise, I think this is how we use a table. Right? It's a very simple way. Right? The table looks very easy to use, and the model is also quite easy to draw. You put them together, you can actually solve a problem that carries 4 marks. And it looks quite hard at first, but once you understand, it's actually very easy. Alright, so I will see you in the next lesson, and stay tuned for the next lesson.